That leads me to this little yellow booklet here. Anybody in here own an airplane that was built before 1974? You guys remember getting this guide in the mail? Okay, well if you don't remember getting this guide in the mail, then that is a sign of aging. Because we mailed about 140,000 of these out to everybody, owners of airplanes older than 30 years, back in 2003. So it would have been any airplane built before 74. The other thing is that you may not have your address right in New York City. Anyway, we put this little booklet together. It's available on those websites. If you can find that website, there should be a prize for you. Google it if you don't have it. And I've got a few copies up here, so if somebody wants one, come see me afterwards. Google it's the easiest way to find it, or go to the EAA or the AA websites. And I do want to comment that I didn't hear about this until a couple days ago that Darrell Lentz recently passed away. His name's in here. He was very key in helping us put that guide together. So it hurt me when I heard that he tragically passed. A little bit about this guide. It's got two key things in here. Records research, how and why, and I'm not going to go into a lot of the details here, but it's basically, for Oak City, you can send your N number to Oak City, and for $5 you get a CD that has everything that we know has been done to that airplane. So what's your airplane's history? Does your airplane match the paperwork, and does your paperwork match the airplane? Those are good things to know. Do you have model-specific issues? That's where you can work with the type clubs. Certainly any damage history, you can see that out of the repair stuff that would be there, as well as checking those items there. So that's one of the good best practices, like we like to call it, of finding out about how a specific airplane or maybe a specific airplane model is behaving. And then the other thing we've got in this guide is special attention inspections. And the thing there is we recognize that there is no difference, there are no different requirements from our perspective for a brand new airplane's annual inspection or for an airplane that's 50 years old. So what we're looking at saying is maybe we should have some special attention inspections, and we talk a little bit about how we might do that. We've got a generic checklist and so on and so forth. And the way I equate this is, back when I was in my 20s, I went to the doctor for a physical. And the doc punched around on me and he says, "Marv, you're good to go. Your inspection's clean, fine." When I went in for my 40s, after I was 40 for my annual inspection, he said, they poked around on me a little bit more, and he said, "But we're not done yet." And he did one of these. He pulled out this thing. You get the point. It was an intrusive inspection. And when I went in after I turned 50, I had an additional intrusive inspection. And there's somebody in the back of the audience who's supposed to say, "Wait till you're 60." Same sort of thing with an airplane. This is the way we treat our bodies. We know that we need to start looking for things the older we get. And we've got a lot of medical evidence that says you're really stupid if you don't. We should be applying that same philosophy to airplanes. Okay? So I'm going to wrap up. I don't think I have got too many more slides, so hopefully time-wise I'm okay. Where to look, when to look, how to look. Follow those manufacturer's instructions for this. Report those SDRs. Utilize the expertise of the type clubs. They can be the experts in many cases, especially for those orphans. And then watch for precursors. And here again, severe use airplanes could be fleet leaders. Is what you're maintaining affecting something else? Are you doing something in there that may cause a problem somewhere else? A little bit about your circuit breakers. We did some research over the last 3 years. We've torn completely down 2 Cessna 402s and 1 Navajo. We're in the process of tearing down a Beech 1900 now. It's an autopsy, basically. And one of the interesting things we found out of that is if you don't cycle your circuit breakers, they will become ineffective. So if you cycle them, that's actually good for them. What happened is the first time they went through, they found out like a third of the circuit breakers on this 1402 didn't work. And then they realized they hadn't done something quite right to the protocol of how they did them. So they recycled them again, and they found out that 20% of them didn't work. So then they recycled them again and it went down, and it kind of leveled off. They ended up with about, I think, 10% of the circuit breakers didn't work, but they found all 3 airplanes, as they cycle those circuit breakers, they start coming online. So the moral of the story there is cycle your circuit breaker if you can. Okay. That led me into this one. I already talked about that. That's where we are now. We found a little bit of this. We found a lot of electrical wiring anomalies. Okay. We also discovered that it's not really hard to determine where and how to look and fix those precursors. Now, the where and the how to look is kind of interesting because, like the T-34 structure or the 402 structure, there are some places that are very critical that you can't look. So if you can't inspect for it, then you've got to do something else. Okay, and these are some findings from the teardown. Now, these are photos right out of either the 402s or the Navajos. These are photos from what they found when they went in there and took a look. And as you can see, that airplane, that wiring is supposed to have a grommet around it, right? Well, it didn't. It was just sitting there rubbing, just like that. Okay? This is an example. This is a big iron photo. But this is an example of what can happen when you get a wiring rubbing against that metal, and it's going to rub and rub and rub and eventually cause a spark. In this case, cause a little fire in there. So here's a case where that could have been taken care of, should have been taken care of, and it can cause a problem eventually. Okay, here are some more photos out of the teardown, and somebody accused me of saying that that was my 1993 Mercury battery cable, but it's not. It's out of an airplane. And here's an example of these sorts of things. You've got that's an overheated connection. There's some insulation that's starting to go away. And there's a case where we had a fire. Here again, this is a big iron picture, but that's the sort of thing that can happen if you let those little things get away from you. Okay? And we found over 100 anomalies, 100 wiring anomalies similar to this on each of the airplanes. So it wasn't an isolated instance, there were a lot of them. Okay? There's another one, that's a wire bundle that's been tied off very nicely there. I'm sure you guys have never seen anything like that. I'm sure you've never seen any just wires hanging loose. And then what's this? This is the fuel. That's the normal crud that's going to accumulate. That's the fuel if there's a spark there, right? And that can lead to something like this. Now, there's an interesting story about this one I got to tell you. You can see there's a machine screw right there, and there's another one right there, and there was a third one right in there that they had screwed right through that. This is another big iron picture, screwed right through there, right into those wires and caused a short, which caused a fire. The interesting background behind this is, for whatever reason, the mechanic decided to move the little plate that houses the airworthiness certificate. That's the truth. That was that little thing that holds the airworthiness certificate on. It was I think it was an MD product, but they were just trying to comply, I guess, but they weren't paying attention. Now this is I've got 2 or 3 more slides. This is true story. This is no joking here. This is a Navajo with winglets. This airplane had an STC, not this particular airplane, the story I'm going to tell, had an STC to put those winglets on, done 17 years ago, something like that. Okay, the STC said run the wires, I guess they had to rewire the tip light. Run the wires through the leading edge. But instead, this STC was improperly done, and the wires were run through the main wing area, and they weren't properly. I'm not an electrical type of guy, but you properly stand off the wires. You just don't let them hang in there loose. Well, these wires were hanging in there loose. And over 17 years of sitting there rubbing on a rib or something like that, they wore through. So now you've got a live wire that's broken too. Okay, that was problem 1. Totally independent of problem 1 was problem 2, which was a broken fuel vent nipple. This is just a close-up of that. And so I've got this wire running through this wing bay, and I've got this bladder tank here with a broken fuel vent. So you can imagine what's happening here. Evidently, the story is this airplane had flown in the morning, had a half a tank of gas, had landed someplace in the morning, nice sunny morning, stayed on the runway for a couple of hours, and when the guy went to take off, he got halfway down the runway and the wing blew up. And that's because he had fuel, which is the fumes, because of the fuel vent broken, and he had the ignition because of the spark from the wire. Now, fortunately for him, and whoever else was in the airplane, that happened when he was on the runway still. If it had happened 30 seconds later, that would have been a fatality probably. So those are little things that, we found scads of these little wiring issues on all those teardowns. And it's not just one thing that can get you, it's usually a cascade of things, right? Well, there's an example of a cascade of things that you guys have probably seen countless times. Fix those little things, guys. Okay, one more slide about cost. I am of the mind that we should be looking at airframes just like we look at engines and say, it costs me so much to operate an hour to operate my engine because I know I have to overhaul it at the end of 2,000 hours. Airframes should be the same way. Instead of, okay, I'm going to account for an annual inspection, but I'm not going to account for something that a mechanic might find. You guys have probably heard that from your owners. Oh, I can't afford to do that. Find some other way around it. What we did, we had a guy in our plane who owns a Baron, and I had him put this slide together for me, and he basically looked at insurance costs, fuel costs, tie-down costs, maintenance costs, and engine reserve. And he said, if I double my annual inspection, I spend so much for an annual inspection, I just double that every year. This is what it does to the operating cost. That's about 10%, regardless of the kind of airplane you're using. So the moral of the story there is, pay me now, pay me later sort of thing. We should be saving up, as airplane owners, we should be saving up for old airplane maintenance. Just like, it costs more to operate me now than it did when I was 20 years ago. Okay. The fleet's diverse, be around a long time. Aging is inevitable. We've learned a lot from the aging airplane program, which primarily affected big iron, but we've learned a lot from that. Unusual usage is the fleet leader. Report those service difficulties and fix those little things. Do we have time for questions? And if you've got anything written down on a form, turn it in to somebody. Question? Yes, sir. Well, composite's supposed to last for a lot longer. It doesn't fatigue in a normal way metal does. I'm no composites expert, but composites haven't been around long enough for them to manifest all the problems we might see in terms of deterioration. They're not going to age on a cycle basis, but what might happen in terms of how they absorb moisture and things like that, we really don't know. We've tried to simulate it in testing and that sort of thing, but we'll see. We'll see. Any more questions? Okay. Thank you.